Hi students, welcome to lecture number 5. Okay, in this lecture I will explain you what are the applications. Okay, what are the applications in in FEM. Okay, applications of FEM. You can see here there are many applications, more than uh, 150 disciplines of engineering, disciplines of uh, uh, disciplines of engineering disciplines of engineering used this FEM. Okay, used this FEM. You can see here structural mechanics and fluid mechanics and earthquake engineering and heat transfer and mass transfer and electric and magnetic field problems and biotechnology and biology and also many branches of engineering. Structural analysis, in order to solve beam problems or building components problems, we use these finite element methods. And in order to solve the fluid mechanics problems also, we use this FEM. We apply this finite element methods. And for earthquake engineering also we use this FEM. On heat transfer, okay, heat transfer, this is for mechanical engineering. Okay, mechanical engineering. And this first three will include civil engineering. Okay, civil engineering. And mass transfer and electric and magnetic field problems, this is for a triple E or something. Okay, triple E or EC students, EC branch. Okay, and biotechnology, they are this FEM is used in biotechnology, also in biology and many more branches of engineering. Not only in aeronautical engineering, they use aeronautical engineering and productive engineering, productive engineering, and many more branches. They use these finite element methods, okay, to solve their problems or to design the particular things. Okay, coming to, you can see here okay, you can see here, based on these applications of finite element problems are classified. Finite element problems are classified at two types. One is the structural problem, another is non-structural problem. Okay, structural problem is what we do. Let us say this is a bar element. Okay, I apply some, let us say I apply some axial load as P, and having the bar having the length and having area of the cross section as A and Young's modulus E. Then in finite element, what we'll do, structural problems are nothing but bar element, beam element, test, all these things. What we'll do, we will find the displacements at each node. Okay, displacement at each node. And let us say this is a beam. This is the beam. This is a continuous beam. Okay, let us say this is the first node and this is the second node and this is the third node. In this, what we will find at node 1, what is the what is slope. At node 1, what will be the slope. At node 1, what will be the displacement. At node 2, what will be the slope. At node 2, what will be the displacement. At node 3, what is the displacement. At node 3, what is the slope. Okay, what is the slope. This, just by using this simple equation, the stiffness equation, k into u. Okay, by using this, just if you want to use displacements, then you will force by k, then you will get the displacements at particular nodes, or not displacements, or slopes. Okay, this is all about this structural problems. By using displacement, obviously by using displacement we will find the stress and strains. Okay, by using the relations between stress and strains. Similarly, for non-structural problems, what we'll find fluid pressure at temperature at each node. In structural problems, displacement at each node. In these non-structural problems, fluid pressure at each point. Fluid pressure at each node. From these properties such as heat flow and fluid flow for each element is calculated. How, if you know this fluid pressure at each point, then we'll find how the heat is flowing, how the fluid is flowing, something like that. Okay, this is all non-structural problems. Non-structural problem. This is all about structural problems. Then coming to historical background of this FEM, generally the first who coined FEM is Clock. CLOUGH, Clock. He is an structural engineer or is earthquake engineer from University of Berkeley. Okay, earthquake engineer from University of Berkeley. First coined the term finite element. First coined the term finite element to solve plane stress problems. Edward Wilson developed many finite element subroutines to solve complex problems via Fortran programming language. Okay, Edward Wilson is a student of Clock. Then he developed many he solved many complex problems by using this Fortran programming language by writing many subroutine functions. Okay. During 1960s and 1970s, FEM was extended to application in cell elements, cell elements like slab, okay, slab and plate bending and heat transfer analysis, fluid flow analysis, and 3D problems in structural analysis. This is all about historical background. Then you can see here some civil engineering softwares developed by using FEM are StatPro and SAP and ETABS, ANSYS, and there are many other softwares also. Nastron is there. Okay, Nastron, and all these are finite element based developed softwares. Okay, generally we know StatPro is used by all civil engineers, and SAP also, ETAPS and ANSYS were used by mechanical students, and sometimes we use civil engineering students, so we use. Okay, and in order to solve these FEM complex problems, just there are some programming languages. There are MATLAB and Python and Scilab and FreeMat and Fortran and C++. Open all these Python, Scilab, FreeMat, Fortran and C++ are open source softwares. Okay, open source softwares. Just you have to purchase. No, not purchase. You will get free. You get freely. But this MATLAB is very costly. But this MATLAB is very useful to solve this finite element methods. Okay, if possible, I will show in this in this lecture series by using how to solve the bar element by using MATLAB. Okay, by using MATLAB. Okay, this is all. These are about best programming languages to solve the complex FEM problems. Okay, these are the some important. Some important softwares used in civil engineering which was developed by using FEM, and you can see this is the historical backgrounds of this, and these are the based on application finite element problems are classified as structural problems and non-structural problems. Okay, anyway, thank you for hearing this lecture. Thank you.